Alright, here's solving systems group test. Here's number 1. We have find the intersection point. You're given two lines, they intersect at this point given. You need to find the ordered pair. So when trying to find an ordered pair, you always start on the x-axis at the origin. So we notice to the left, so we're going to go 1, 2, 3. So I went over 1, 2, 3. I went over -3, and then I went down 1, 2, 3, -3. So this ordered pair is -3, -3. That is the point of intersection. All right, number 2, create tables for both DoorDash and Uber Eats that compare the price of their delivery service. So we're going to use a table algebra to explain both companies and what they would charge when they would charge the same amount. Okay, so starting off with number 2, we are catering our next business. The DoorDash, we're talking about DoorDash, and it charges the delivery fee of $30 and $7 per person. That per tells you that that's your growth. And they're going to start you off with a delivery fee before you even start making your order. So if I write it as an equation, we're going to refer to y equals mx plus b, which is your slope form. And we know that m is our slope, our rate of change, or our growth, and I'll put growth. And b is our start value. Okay, so if we look at DoorDash, it tells us that the delivery fee is going to be $30. So for 0 number of people, it's going to start off at $30. And if I continue it, my growth, it tells me that it's going to be 7 per person. So I'm going to continue to add 7 every single time. So I'm going to find up until 10 people. I extended your tables. All right. So then I'm going to keep adding 7. And as I do, I get 37, 44, 51, 58, 65, 72, 79, 86, 93, and 100. Okay, so that's DoorDash, but I want to write an equation for that. And again, I'm going to refer back to this slope formula right here. So if I write it out, it's y equals, my growth was $7 per person, so 7x, plus my start fee of $30. Okay. Now I want to write out Uber Eats. So here's Uber Eats. It says that Uber Eats charges $10 per person, and they do not have a delivery fee. So when they don't have a delivery fee, my start is 0, and this 10 per person tells me that's my growth. So my equation for that one is going to be y equals my per person tells me it's my growth, so 10x, and I don't have a start. So if you want to put plus 0, but it's not necessary, I just don't have a start. So I'm going to also find the cost for 10 people. Okay, and it says we didn't start off with anything because it doesn't have a delivery fee. So I'm gonna start off at $0, and then I'm gonna continue to grow because my growth is 10. So adding 10 every time. So I get 10 for one person, 20 for a second person, 30, 40, 50, 60, 70, 80, 90, and 100. So if I look at these tables, I should see a point of intersection. And what I mean by that is my x and my y have the same values. And I'm noticing that they don't until I get to 10. So my point of intersection based off of my graph is 10 and 100. In terms of context of the problem, it's basically saying that 10, because this right here, this 10 represents the number of people. So 10 people for both companies is going to charge you $100. So again, 10 people equals the cost of $100. Okay, that's how you solve it, creating a table. But now I want to go into solving it algebraically. So I'm going to take both of my equations that I came up with. This was DoorDash. DoorDash was 7x plus 30. And then we have Uber Eats, which is 10x. Okay, and so I want to set these equations equal to each other because I'm going to solve it algebraically. And I want to isolate x by itself, so I'm going to subtract 7x. I get 30 is equal to 3x. Get x by itself, divide by 3, x equals 10. So I know part of my ordered pair algebraically is going to be 10 because we know an ordered pair is going to be xy. Now I need to solve for y algebraically. I can take either equation that I want to use, either it's DoorDash or Uber Eats. I'm going to take Uber Eats just because it's less steps for me to do. So that's Uber Eats equation. And now I'm going to plug in x that we found. So then I have y equals 10 times 10, which gives me my y value of 100. So algebraically, I just solved for the same thing with my table. If my table and my algebra if my algebra solution and my tables don't match, I messed up somewhere either creating the table or I messed up somewhere algebraically. Number 3, find the solution to the given table. So just like we did in our second equation with the word problem, is that we created a table and we looked for that point of intersection. So does my x match with my second x? Yes. And does my y value match with my first y value from my first table? Okay, so it's the same thing we're going to do for number 3. We're going to look at our x. Do we have another negative 2 over here? We don't. So 0, we do here. Does y, our output, match our other output? No, they don't. 2, and so on. So now we found our pair. That tells us that when I graph these equations, if I was to create the equations, my point of intersection would be 2, 7. Okay, so we have solved each of the equations using a graph and the algebra. Okay, so we have two equations here. We have y equals negative x minus 1 and then y equals 2x plus 5. To solve this algebraically, they're already both in the form of y equals, so I'm going to set them equal to each other. So all I did is I took my y's and I got rid of them by setting them equal to each other. So literally taking these equations and putting an equal sign between. Now I want to solve this algebraically, meaning I have to isolate x. So the first thing I did was I set them equal to. Now the second thing is to solve for the variable. Okay, so I want to get x by itself. I'm going to add x to both sides. I get negative 1 is equal to 3x plus 5. And if you're asking where am I getting that 3x, well, there's a 1 here, so 2 plus 1 gives me 3. And if I solve for x, I need to get everything away now. I'm moving everything over because I got the x to the right. So now that the x is on the right, I want to get the x by itself. So now I have to move everything away from it. That cancels out. I'm left with negative 6, 3x, and then I need to get x by itself. Divide by 3, where I get x equal to negative 2. So again, when I'm looking at my ordered pair, we know an ordered pair is x, y. So I just found my x value. Now I need to solve for my y value. So in order to solve for your y value, you're going to take either equation, and the equations I'm asking is either this one or this one. I can either take either one that I want to use for my y value, to find my y value. I'm going to choose this one because I'm not a fan of negatives, so I see that when I multiply this one, I'm going to get all positive. So you can use either one. They should give you the same answer. So all I'm going to do is that I found x to be negative 2. So I'm going to plug it in where y equals 2 times negative 2 plus 5. We know 2 times negative 2 gives me negative 4 plus 5, which should give me 1. So my y value is 1. So my ordered pair, my point of intersection, is negative 2, 1. Okay, so now we need to graph these two equations. So the equations that I'm going to graph is going to be this one right here and this one right here. I'm going to color code them. So here is my first one. Let me make this smaller. Give me 2 seconds. Okay, so I'm going to graph equals negative x minus 1. I need to graph this. So if you're familiar with slope formula, we know it's y equals mx plus b, where this is my start at my y axis, and this is my growth slope, which slope, if you recall, it's going to be rise over run. So if I take my first equation, you can solve this two ways. You can either create a table or you can use your slope form and draw out the line. So I'm going to use that really quick. We have negative 1. So here is negative 1. That's our start on our y-axis. And it's going to be negative 1 right here. So it's going to be negative 1 over 1 because this is equivalent to saying negative 1. And my rise is going to be negative 1 and my run is going to be 1. So if I plot it really quick, there's -1. If I rise 1 over 1, it'd be here. Rise 1 over 1 here. Continue that. What I mean by rise 1, I go up 1 and over 1. So now I'm going to create a line. I'm going to try my best to make the best line here. Okay, so there's my, that's going to tell me that's y equals -x minus 1. And I'm going to change it pink so that you know which one I'm talking about. So let's look at when it comes to creating a table. Let's verify that what I just did with my slope and my line, that it makes sense. So I'm going to create a table really quick. Like I just said, this right here is my start. So I know if I start at 0, my output should be -1. Well, we do know that any number next to my x, which is your slope, it is your growth. So if I take that -1, I'm subtracting 1, so I get -2, then -3, by subtracting 1 by my growth. So if I go to plot these should be what I just graphed on my line. 0, -1. I go 1, and then down 2, 1, 2. And then I go 2 through -3, 1, 2, 3. Those are my points. So you can use either method. I'm going to use the table for my second one. You could use the same way that I just solved with rise over run, but I'm going to create a table. So I know that this right here is my start value, 5, when I'm at 0. And I know my growth is 2 because it tells me right here is my growth, which is your slope, your rate of change. So if I add 2, I get 7 and I get 9. So let's graph those really quick. I'm going to create it in purple. Okay, so if I graph that really quick, I have 0, 5, 0, 1, 2, 3, 4, 5. That's 4. 1, 2, 3, 4, 5. Okay. And then 1, 7. So I'm going to try my best to create this line right here. Okay. So there's my line because I only used 2 points because I couldn't graph 2, 9. Okay. So with that being said, we solved algebraically that it was -2, 1. Now we just graphed it with the tables that we created by using our slope forms that we were given. Now I'm going to verify, is that point correct? Algebraically, we solved for it, but let's check to see when we graphed for it. We said it was -2 and then up 1. That is our point of intersection. Therefore, we know we did it correctly in terms of graphing because we got -2, 1 when we graphed, and that's the same thing that we got when we solved it algebraically. I find the intersection point. So I'm going to solve this algebraically, but notice that the last one we did before this one was both in the form of y equals, y equals. If you look at number 5 and 6, they're not nicely set up like that, so we can't set them equal to each other. So instead of setting them equal to each other, I will substitute. So the first thing I want to do is substitute the information that they give us. So they tell us that y equals, and I'm going to plug it in for every y that I see. So if I look at the second equation that I have 3x plus 3. Well, what did they tell us that y is? They just told us that y is x plus 5, and then we have everything is equal to 21. So again, nothing changed. The only thing that changed was my y value because they told me what my y value was. So now the second step that I'm going to do is I'm going to distribute. When I distribute, I get 3x. 3 times x is positive 3x. 3 times 5 is 15, is equal to 21. The next thing that I want to do is I want to combine like terms. Where I have 3x and 3x, that makes 6x plus 15 equals 21. I'm going to isolate, solve for variable. And when I do, I subtract 15. 6x is equal to, what is that, 6? Divide by 6. I get x is equal to 1. And again, our ordered pair is x, y. And so we just found our x value, but now we need to find our y value. And in order to find your y value, you're going to substitute the variable back in. So if I'm substituting my y value, or my x value into either equation, I should get the same thing. So if I have x equals 1, I plug it back in here, and so you can use either equation, but I'm going to look at my equations that are given, and I'm going to look at which one is the fast and most efficient way possible, and I'm looking at this one. So if I plug in, I'm given y equals x plus 5, and I'm going to plug it back in to x. I just found x to be 1, so I have y equals 1 plus 5, where y value equals 6. So the ordered pair, that the point of intersection when looking at these two equations, should be 1, 6. All right, number 6. 6 is very similar to number 5, so what I'm going to do is they tell me to find the point of intersection, or to find the intersection point. I'm given y. I'm going to take that information, and I'm going to plug it into my y value of my second equation. So this now represents negative 2x minus 4. Well, they just told me y was negative x plus 3 equals 12. So the first thing I did, again, was substitute the information they gave me. The second step is going to be distribute. So when I distribute, I get a negative times a negative is a positive 4x, and then a negative times a positive is a negative 12. And everything else didn't change, so I'm leaving it as is. And I'm going to put a plus sign in front of that 4x because we know it's positive, is equal to 12. The next thing I'm going to do is combine like terms. When I combine like terms, I know that this and this are my like terms. It gives me 2x minus 12 is equal to 12. And then I'm going to isolate, solve for variable. So I'm adding 12. I get 2x is equal to 24. Divide by 2, where x is equal to 12. So again, my ordered pair is going to be x and y. We just found x value to be 12. Now I need to find y. So in order to do that, I'm going to plug back in into either equation to find y, to find other variable. So I'm going to take the equation y equals negative x plus 3. And the reason why I chose that one, because it would be less steps for me to do. You can use either equation. So I found x to be 12 plus 3. And that's a negative 12. So negative 12 plus 3 gives me negative 9. So my output is negative 9, where my point of intersection algebraically, we just solved to be 12, negative 9. Solve the system of equations and made an error in the first step. So they told us what step they messed up in. What I want you to do is I want you to describe the error and explain what the student needs to do to find the correct solution. So what I'm asking you to do is to tell me what they did wrong and then solve for it. Okay, so I have two equations that they give me. They're not in the form of y equals, so I can't set them equal to each other, but I know I can substitute. They tell me what y is, so I'm going to plug it in for y, just like we did for number 5 and 6. So my new equation is going to be, if I solve this myself without even looking at their work, is this. And we just found y to be x plus 1 is equal to 3. So if I look at my version of my steps and compare it to theirs, it looks like they set them equal to each other. And we know we cannot do that because they're not both y equals. So that's where their mistake was. Their mistake was not substituting. Okay, so now if I solve this algebraically, I need to distribute. So 2x plus 3x plus 3 is equal to 3. Combine like terms. This is my like terms. I get 5x plus 3 is equal to 3. Subtract 3. I get 5x is equal to 0. I get x is equal to 0. So therefore, I found my x value of my ordered pair to be 0. Now I need to find y. To find y, I use either equations that I was given to find y. I'm going to use the second one just because it's in a nice form where it's going to be easy to solve in less steps. We found x to be 0 plus 1, where y is 1. So my point of intersection is going to be 0, 1.